So today's video we're going to discuss about joint probability mass function. In the previous section we have discussed what is a random variable, what is a discrete random variable and what are its associated functions, and some of its were probability mass function. So coming to probability mass function, we had a discrete random variable and corresponding to which we could find the probabilities. So here, when it comes to joint probability mass function, so we have two random variables or a pair of random variables, that is x comma y. So here we have, since we have a pair of discrete random variables, these random variables x comma y is called a bivariate random variables. So here we have bivariate distributions. This x comma y pair assumes values x1 y1, x2 y2, etc. xn yn from the real plane. So then the probability of the event x is equal to xi, comma y equal to yj is denoted by f of xi yj or pij, and this value, this probability value is called the joint probability mass function of x comma y. So f of xi yj is equal to probability of the random variable x taking the value xi and y taking the value yj. So since this is a probability mass function, since there are two random variables x and y, this is a joint probability mass function. So it satisfies some properties of the similar to the probability mass function. So this function satisfies the properties f of xi yj is always greater than or equal to 0. We know this is a probability value. This f of xi yj is probability of xi taking the value, x taking the value xi and y taking the value yj. Therefore, that is a probability. Therefore, it must surely be greater than or equal to 0 for all xi yj. And also, we know when it was the univariate case, that is when we were considering the probability mass function, the summation over I f of xi must be 1. So here we have a plane, that is summation I and j. We have two random variables x and y. So summation over I, summation over j, f of xi yj must also be equal to 1. So this is what a probability mass function is. So when we have a bivariate discrete random variable, we consider this joint probability mass function.